This video is on some applications, and so we're going to be using quadratic methods in order to solve these. Okay, so our first example here is a problem about work. We have two pipes that can be used to fill a pool. Working together, the two pipes can fill the pool in 6 hours. The larger pipe can fill the pool in 3 hours less than the smaller pipe can alone. Find the time to the nearest tenth of an hour it takes for the smaller pipe working alone to fill the pool. So the way that you start all of these problems about work is the same, and that's to make up a table. And in your table, what you want to have is along the top, you want to have the time, and this is to complete the job. And then the other column is going to be part in 1 hour. And the second column, the part that they can do in 1 hour, is always going to be 1 over however long it takes them to complete the job. So if you're painting a table, for instance, and painting the whole table takes you 2 hours, then in 1 hour you can do half the table, right? You do this half in the first hour and this half in the second hour. So even if it takes you 3 hours to paint this table, then you can do this first third in the first hour, and then the second third in the second hour, and the third third in the third hour. And so the part that you could do in 1 hour would be 1/3, and it's always going to work out like that, where it'll be 1 over however long it takes you to do the entire job. And then the rows will be whatever it is that you have doing the work. And so we have the larger pipe and the smaller pipe. And then you always include both, and you can have more than one thing doing work, and so the last column is always going to be everybody all together. Most of the time when we do them, we only have 2 items that are doing work, and so it'll be 3 rows, the larger, the smaller, or whatever the case may be for the workers. And then the last one is always the both. Okay, so we know that working together, the 2 pipes can fill the pool in 6 hours. So both of them together can fill the pool in 6 hours. And so the part that they can complete in 1 hour is 1/6. The larger pipe can fill the pool in 3 hours less than the smaller pipe can alone. So X is going to be the smaller pipe. And then we'll write the larger pipe in terms of the smaller pipe. And it takes the larger pipe 3 hours less than the smaller pipe, so that would be X minus 3. And then the part that the larger pipe could do in 1 hour would be 1 over X minus 3. And the part that the smaller pipe can do would be 1 over X. So again, if we go back to this painting a table example, and let's say there were 2 people that were working on painting the table, and it took one person 2 hours, and we'll use some easy numbers to do this. One person, it took 2 hours to paint the table. The other person maybe took 4 hours to paint the table. Maybe they got a really small brush or something. Who knows? But anyways, so this person can do half the table in an hour, and this person can do 1/4 of the table in an hour. And so when you add these 2 together, that's how much they can do together in an hour. And so that's what we're going to do here. So we're going to write an equation for what they can do together in an hour. So that would be the part that the larger pipe can do in 1 hour, 1 over X minus 3, plus the part that the smaller pipe can do in an hour, 1 over X. And it's equal to the part that they can both complete in 1 hour, which is 1 over 6. And again, they all work like this. You fill out this table, and it's always going to be the sum of the workers equals them all together. Okay. So now we want to solve this. And to solve this, because there's fractions, we want to multiply by the least common denominator. And all of our denominators are different. We have X minus 3, X, and 6. So 6X times x minus 3 is going to be our least common denominator, and we're going to multiply all of those terms by that least common denominator. So I'm going to go do that over here. So I have 1 over x minus 3 times 6x times x minus 3 plus 1 over x times 6x times x minus 3 equals 1/6 times 6x times x minus 3. So when we multiply 1 over x minus 3 by our least common denominator, the x minus 3's cancel, and we're left with 6x. And 1 over x times 6x, x minus 3, the x's cancel, and we're left with plus 6 times x minus 3. And that equals, when we multiply 1 over 6 by 6x times x minus 3, we're left with x times x minus 3. Now we need to simplify this, so I need to distribute this 6 and distribute this x. That gives me 6x plus 6x minus 18 equals x squared minus 3x. Combining like terms, I have 6x plus 6x, so that's 12x, minus 18, and it's equal to x squared minus 3x. This is a quadratic because I have an x squared term here, so that means I need 0 on one side, so I'm going to bring the 12x and the negative 18 over. So I'm going to subtract 12x and add 18, and that will give me x squared minus 15x plus 18 equals 0. Now we want to see if we can factor this, and we're not going to be able to. 18, the factors of 18 are 1 and 18, which won't give us a 15. 2 and 9 won't give us a 15, and neither will 3 and 6. So we can't factor it, which means plugging it into the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to have positive 15 plus or minus the square root of negative 15 squared. And don't forget to put that in parentheses because you have to square the negative 15, which will be a positive number. And then minus 4 times a, which is 1, and then times c, which is 18. And this is all being divided by 2 times a, but our a is just 1. Okay. We have 15 plus or minus the square root of negative 15 squared, and that gives me 225. And then minus 4 times 18, that gives me 72, and it's all being divided by 2. So that's 15 plus or minus, we have 225 minus 72. So that's going to be the square root of 153. All over 2. So these are our two solutions. Do both of these make sense is the question, though. So this x is how long it takes the smaller pipe to complete the task, and the larger pipe is x minus 3, so we would have to subtract 3 from this to get the larger pipe's time. And so do both of these make sense for the larger pipe is really the biggest question we have. And so 15 plus the square root of 153 over 2, this is going to work. This is going to be fine for sure for the big pipe. The one that I'm curious about is the other solution, the 15 minus the square root of 153 over 2. And so this was about 12.393 or something like that. Let me just check. 12.369. So if I take 15 minus 12.369, I get 2.631, and then divide that by 2, and I get 1.3155. Now, if I subtract 3 from that, that would be a negative number. Oops, that's not a very good 3 there. Let me fix that. Well, I'll just write down what it is. It's negative 1.6845. And so this can't happen because this is the time for the larger pipe. And you can't have a negative time for filling it. So this solution doesn't work, and this is the only one that will work here. And find the time to the nearest, oh, it does say to the nearest tenth of an hour it takes for the smaller pipe working alone. And so we only need the smaller pipe's time, and so we want to calculate what that is. So 153, square root of that was the 12.369. So it's going to be 15 plus 12.369. We only want it out to a tenth. Bring it out a little bit further while you're doing your calculations, though, just so that you know your number is accurate. Okay, so 15 plus 12.369 gives us 27.369. And then we want to divide that by 2. And when we divide that by 2, we get 13.6845. So it takes the smaller pipe, and we want to round this to the nearest tenth. So we have an 8 in the hundredths position, and so we want to round this to 0.7 hours to fill the pool. Alone. Okay. So now on to our next one. Suppose that an open box is to be made from a square sheet of cardboard by cutting out 2-inch squares from each corner. If each box is to have a volume of 128 cubic inches, find the original dimensions of the sheet of cardboard. So draw a picture of your situation. Normally there's a picture given to you for these problems already anyways. So we have a sheet of cardboard, and we're going to cut out these 2-inch squares from the corners. And then we're going to fold these edges up, and it'll create an open top box. And our volume is 128 in cubic inches. So we don't know how big of a sheet of cardboard we have. We do know that it's square. And so if this total length is x, what is this shorter length, the length of the side of the box? So if this entire length is x, and this length is 2 that we're cutting out, and this length is 2, we're really cutting out 4, so that's going to be x minus 4. And so the dimensions of our box, when we fold up these edges, this side is going to have a length of x minus 4, this side will be x minus 4, and its height, which is this length, will be 2. So to calculate the volume, which is 128, is going to be 2, the height of the box, times x minus 4 times x minus 4. The length of this side times the length of this side. So now we can figure out what x is by solving this equation. We have 128 is equal to 2 times, and then do FOIL on this. You'll get x squared minus 4x, and then plus 16. And also, before I get too carried away and forget about it, I have 2 times this big quantity here. So we can divide both sides of this equation by 2. These 2's will cancel, and 128 divided by 2 is 64. And over here then we have x squared minus 8x plus 16. And this is quadratic, so we need 0 on one side, so we're going to subtract 64 from both sides of the equation. That gives me x squared minus 8x minus, and 16 minus 64 gives us negative 48. And that equals 0. So can we factor 48 so that the sum will give us 8? So 12 and 4. And we want them to be different signs. So if we have a negative 12 and a positive 4, that would add to give me negative 8 and multiply to give me negative 48. So we can factor this as x minus 12 times x plus 4. Set x minus 12 equal to 0, we get x equals 12. Oops. And then set x plus 4 equal to 0, and we get x equals negative 4. This solution doesn't work because we can't have a negative length to our sheet of cardboard, and so the dimensions of the sheet of cardboard are 12 inches by 12 inches. Okay, and that's the last example about this stuff, so if you have any questions, let me know.